No. Hi everyone, welcome again on this live session on the MOOC New Energy Technologies. Today Olivier Catera has asked me to welcome our guests. We have Mathieu Lefebvre and Youssef Tazi.
Exactly.
They will introduce themselves and then we will start with your questions. We know that you're connected from all over the world. You are 4,200 participants in the MOOC. And so we are very happy this week to speak about biogas energy. So Mathieu, could you please introduce yourself?
Yes, for sure. So hi everybody, I'm really happy to be here. My name is Mathieu Lefebvre. So I hope you already watched the speech on biogas, and I'm the CEO of Waga Energy, a new company dedicated to landfill gas upgrading. And I'm really happy to be here tonight and try to help you to understand the biogas market.
And yourself?
And I'm Youssef Tazi. I am a sales engineer at Air Liquide Advanced Technologies in the membrane technology that develops Air Liquide. And I am replacing today our expert, Lucille Cadic, that couldn't be here. And I'd be really happy to answer all your questions.
Okay, so we will start with the first question that was sent to us. This is, producing electricity from biogas is still relatively rare in most developing countries. Is there any major, reliable, high-quality technology available on the global market? If yes, please elaborate on this.
No. So perhaps I propose to start. Is it really a question of technology? If the market is not as much developed today, is it because the energy produced from biogas, so like electricity produced from biogas, is cheap enough or not? I would say that there is a lot of technology, but technology is not sufficient. You have to find a good business model and to achieve the grid parity or be as close as possible as to the grid parity to expect to expand greatly the market. In this sense, I would say that probably that biomethane, so upgrading biogas to biomethane will probably develop faster than electricity from biogas because the energy efficiency is significantly higher and the biomethane production cost is closer to grid parity compared to electricity. So yes, there is mature technology but to produce electricity from biogas, but these technologies are not suitable to achieve the grid parity and to develop as fast as what we would expect.
Exactly, and I think there is maybe another thing that we have to take into consideration in the business model as well is the number, for example, of entrants. So, for example, in our business model, we have to develop a project, and the price will be dependent on a lot of things. So it doesn't depend only on the technologies, because as Mathieu said, there are many technologies that are available in the market for electricity production and for biomethane production. And the business model is the main part of all the projects. So we have to, for example, to secure the number of our entrants, we have a business model to achieve and to reach if we want to be profitable enough, and if we want those technologies to develop as quickly as we want them to develop.
Okay. We go to the next question now. Is it possible to produce hydrogen for biogas instead of methane?
So I think the question is hydrogen from biogas yeah. Instead of for biogas. Yeah. Yes, for sure. First of all, you have to know. I don't know who asked the question, but you have to know that hydrogen today comes from methane. For something like 95% of the hydrogen produced worldwide comes from methane. So yes, it is possible. Nevertheless, I would say that the mature pathway today is to upgrade biogas to biomethane, which is a renewable substitute of natural gas, and from the methane, through what we call a reformer, a steam methane reformer, produce hydrogen. So I would say that the next step is going to be biomethane. Biomethane as a renewable gas for the mobility or for the heat. And the step after will be hydrogen from green sources like biomethane.
Yeah.
Thank you. Pretty much everything, yeah.
Another question would be, in Europe or in the world, is there any GT, gas turbine, or CCGT plant under operation, project powered with biomethane?
That's a nice question. In fact, a GT, a gas turbine, a lot of landfill gas, which is a kind of biogas produced from landfill, are equipped with gas turbine to produce electricity. Why? Because the landfill gas is really poor in methane, and gas turbines are suitable for this kind of gas. So I would say yes, but not that much on anaerobic digestion, where internal combustion engines are preferred for the robustness and the energy efficiency.
Okay.
So yes, there are already gas turbines operating with biomethane in the world.
All right. Would like to add anything?
Yeah, this is what I added. So
okay.
I just said yes to the question. In the world, there are GTs operating biomethane. Yeah.
Another question would be: can quality of agricultural waste be an issue on yield for the production of biogas?
Yeah. I think it's definitely the quality of agricultural waste, but also the type of agricultural waste is very important and can be an issue for the production of biogas. So, for example, depending on our entrance, we will have a different quality and a different, let's say, a percentage of CH4, which is methane, in our entire gas. So, for example, if we have mostly or only agricultural waste, our let's say our percentage of methane in the biogas will be less. So we have, for example, to add some industrial oils or some things. We have to have the right, let's say, mixture. Yeah, exactly. We have to have the right mixture for our methane to be enough in the biogas before upgrading it. For example, if you want to upgrade the biogas. So yeah, it can be an issue. I don't know if you have anything to add, maybe Mathieu.
No, perhaps just a few key metrics. I'm aligned with what you said. I think we have addressed this in the biogas topic this week. There is a substrate with a very low methane yield, like manure, and substrate with a very high methane yield, like oil from industrial or agriculture, which could achieve 300 cubic meters per ton on the good mixture, mixing everything. Give the best result, for sure.
Okay. There are certain ways in which the biomethane can be used. However, the participant says, I was wondering if you can please help me to understand which is the best possible final product which gives highest returns.
Yeah, well, anyways. Well, the thing is that for the moment, biomethane, for example, relies a lot on subsidies and feed-in tariffs and a lot of things. And if you want to inject it to the grid, it's a possibility, and it's a good possibility because we have less reliance on natural gas, for example. There are some scenarios, and we have seen it in the MOOC, that from here to 2030, biomethane will replace 10% of the total gas that we inject into the network. But for me, the most important and the most valuable, well, let's say, use of biomethane is using it in mobility, because in mobility, the prices are quite high. So the production of biomethane is very competitive, and it competes with the prices of oil and of diesel, for example. And also, it has a lot of environmental benefits. For example, reduce by 90% the CO2 or the total emissions that we inject basically into the air, and that can have, for example, health issues on the populations, etc. So for me, the best way the best valuable way for biomethane use is using it for mobility.
I fully agree. That's really clear, and many studies have shown this. Depends, even if it depends on which return do we talk about. Is it an economical return or is it an environmental return? But both of them are fulfilled if we use the biomethane as a vehicle fuel, and especially if this biomethane substitutes the diesel, which is really polluting for city centers. And as an example, in China or India, most of the public transportation are switching from diesel to methane, and tomorrow biomethane, because of the double impact, the city center air pollution and the renewable source.
Okay, this is a topic we've heard on the news recently. Yeah? Mm-hmm. Another question would be, is there possibility to have an international memorandum of understanding for transfer of biomethane from one country to another? I think one country to another, yeah.
Yeah, so that's a good question. We are working on this to harmonize the subsidies on subsidies to enhance biomethane production all over Europe, but yet we have not achieved to this very nice objective. So it is not yet possible to share the certificate of origin or guarantee of origin between countries, especially because local subsidies depend on local substrate, on way of making biogas from mainly the agriculture. So it's quite a complex question, which is addressed for many years, and we hope to achieve to harmonize this in the next couple of years. This could be a very nice issue.
I can't agree more. And, I think you're more the expert on the topic, yeah.
And when you say we, who are involved in the discussion?
Germany, Denmark, Sweden, Belgium, France, most of the countries that are developing the biomethane. Mm-hmm. But one more time, yet it has not been possible to succeed.
Okay. So look a bit into the future. I don't know if you have
this visibility.
Yeah. By 2030, how much in percentage natural gas could be replaced by biogas? And by 2050. So someone wants you
to want to have a really good visibility on the future.
Maybe
so we will use our work.
Exactly, yeah. Maybe by 2030, what I know is that in France, 10% can be replaced. 10% of natural gas can be replaced by biomethane, not biogas. Because if you inject it to the grid, it's biomethane, and if not, it could be biogas or biomethane at the moment.
And your sources for that?
Sorry.
Your sources?
There are some. For example, there are some in the MOOC. For example, our second, Lucille Kadik, and the person who spoke before. Have said it in the studies they have done. Yeah. So I cannot give you the source like this directly, but it has been done by economical
we can share it online on the forum.
Yeah, exactly. We can definitely share it online on the forum afterwards. And by 2050, I don't personally have a visibility of it. I don't know, Mathieu, if you know any studies that have been done for.
In fact, it's quite a complex question on a specific question, a country-specific question. If you are in Africa or in Norway or in Ireland or in France, the picture is really different. Mm-hmm. So I agree with Youssef. 10% in 2030 could be a good objective for France. And it will also depend on the energetic choice of every country. We have to decrease the global energy consumed in every country, and then the share of biomethane will change. There is countries like Denmark that claims to achieve 100%. So it is possible, and even in France, it could be possible to replace 100% of our fossil natural gas consumption by biomethane. But this means that we have to reduce the methane consumption through energetic efficiency in building and industries. And this means that we have to also develop the biomethane production with more means than today. So I would say from 10% to 100%, depending on country and depending on politics, mainly politics.
Okay, thank you. Another question is, biogas fuel cells were mentioned in one of the lessons. Can you comment on working principles and advantages, disadvantages versus hydrogen?
I'll let you answer, Mathieu, I think.
Yes, so biogas fuel cells are in fact not the same fuel cells than the fuel cells used with hydrogen. We are talking about high temperature fuel cells, so SOFC, solid oxide sulfur fuel cells. We compare this fuel cell with electricity production, so with a gas turbine or internal combustion engine. The advantage, it's not a comparison with hydrogen, in fact. The comparison between biogas fuel cells has to be made with electricity generation from biogas through a turbine or a gas engine. Why we are interested in using fuel cell fueled with biogas? It's because of the energy efficiency. A fuel cell has an efficiency that can achieve 50% electricity efficiency, while an engine will achieve, due to Carnot cycle, 32, 33, 34% electric energy efficiency. So it could be interesting, but these fuel cells are really sensitive to the pollutants. So it's not mature today. It's still under development. And the objective is to increase the energy efficiency.
Mm. We will learn a lot more about the hydrogen cells, fuel cells, next week with experts from Air Liquide as well.
In Japan, Japan has really developed strongly the fuel cells fueled with methane for domestic application. So electricity at home on water, hot water, for showers, etc. So this is already on the market, available. But switching from methane to biogas is quite complex due to the low quality of this gas and the impurities like hydrogen sulfide, which pollute the fuel cell and reduce the lifetime.
Quite technical, huh? Indeed. Another question now. What is the lifetime of landfills in order to obtain biogas?
So
our expectation.
Yeah.
Again.
So landfill is
quite technical. Happy you are
one
here,
of my
Mathieu.
domain. Yes. So thank you for the question. Usually, a landfill has a lifetime of 30 to 50 years, meaning that when you deposit garbage in a landfill, the anaerobic digestion will take place after a few months. The gas will start to produce, and then the gas production will decrease slightly for years after years and years. So a landfill lifetime is between 30 to 50 years. On this, the operating lifetime depends on the size of the landfill. You can fill a very large landfill along 10, 15, 20 years, and then you have still long biogas production for the next 10 to 20 years.
Right. Thank you. How can you solve the problem of flow rate of biomethane, as it is very low in comparison to natural gas? So we will read that again. Huh? How can you solve the problem of flow rate of biomethane, as it is very low in comparison to natural gas? Incorporating turbines sound a bit complicated to me.
I don't personally see the problem of flow rates personally. I don't think there is any problem of flow rates. Maybe the person wanted to talk about the pressure or something.
Perhaps I agree with it. It's quite complex to understand the question, so I will perhaps propose to re-ask the question. But perhaps the thing is, we are not talking about the gas turbine, combined cycle gas turbine for really huge application. The gas turbine we use on the biogas field are really small. So it's not a matter of flow rate. Manufacturers have developed special products for small flow rate of biogas. So it's right now it's not a problem with if you use a dedicated material, a dedicated gas turbine. Usually, a gas turbine is between, I would say, 200 kilowatts to 1 megawatt, 2 megawatt, 3 megawatt. It's really lower than the big gas turbine fed by natural gas that produce on a centralized way gigawatt of electricity.
All right. So if we understood well the question, it's fine, and if not, you can rephrase it, and we will take it again and try to answer it better. So another one, if you're ready to take another question. Is it realistic to say that 1/3 of the energy in France will be produced by biogas according to the negawatt scenario? What is the negawatt scenario then?
The negawatt scenario is made by an association that promotes a scenario where the consumption is significantly decreased and the renewable production is significantly increased, and the both of them fit together. So I would say yes, this scenario is really well developed and constructed, but now I would say it will depend on us. Mainly, are we able to decrease our energy consumption, to stop to waste the energy and to waste our food, etc. And it will really depend on politics to, I would say, put a significantly higher price for energy and to put the renewable energy production. Yes, it's realistic. It depends on us and politics.
Yeah.
So Youssef, if you want to complete, you know the negawatt scenario?
I didn't really know about the negawatt scenario before, but I can say that, like as Mathieu said, if politics wants it, for example, we've seen the cases of other countries like Sweden, like Denmark, etc., where biogas is much more used than here in France, or for example, our neighbors, Germany, which use biogas much more than us. We can definitely reach such scenarios or such values. Sorry. The only thing is that the politics should implement, let's say some feed-in tariffs, some more efficient feed-in tariffs, some more efficient subsidies, etc. That could help and push more people like to develop their projects on the field of biogas.
Okay. So next question would be, this is someone saying, I am looking to start a venture for biomethane in India or Qatar, but I am facing difficulty to find a suitable market. Can you please help me with certain options in these countries?
So,
bit of consulting.
Yeah. To develop biogas at the really local specific market and today quite politic depending market, you need to really understand properly the local specificity. I mean, what is for natural gas grid quality prescription? Can you achieve this quality to inject into the grid? Are you authorized to inject into the grid? What are the substrates available around the country? Are you authorized to make an aerobic digestion plant? What size? What would be the price to produce the gas? So, and this depends on administrative regulation, regulated market, etc. But Qatar is much more complex than India, I think. But well, it's not really easy to answer this question. But looking in detail of what is asked, you said perhaps.
What would be the question you'd ask yourself? Maybe if you do not have the answer to. What would be the questions, maybe?
Maybe the first thing to do, as said Mathieu, is do a market study to see how much, for example, entrance we can get. How much entrance we can secure, how much, for example, if we do biomethane projects, how much gas we can inject into the grid, the specificities of the grid. For example, in the UK and in France, the specificities, sorry, are totally different, are quite different. I wouldn't say totally different, but are quite different. So you have basically to understand your markets. For me, it is the first thing to do before. Basically, you move afterwards, but yeah, definitely you have to define the specificities of the markets.
Yeah, and what will be the bioenergy price
Yeah, exactly.
To make a sustainable business model.
So are they subsidized as well subsidies as well? Are they feed-in tariffs? Are there any incentives that, for example, the countries are doing to help the development of those projects?
A biogas project mixed the waste market. So you have to understand the waste market. What are the waste available? What are the price for this waste? And also the energy market. That the energy companies are happy with this gas or with this bioenergy, what would be the price, what would be the specification, and you have to make this link between the waste and the energy. And once you have studied this, then you can start to make a business model and develop the project.
Okay, I'm sure this is helpful. Biomethane injected into the grid is identified by guarantee of origin certificates. What is the value of a 1 megawatt certificate traded on the French market and on the European markets? You take yours.
I take
I think I need to answer the question.
Very nice question. It's really hard to say right now what is the value of one guarantee of origin in France. We have seen, I would say, everything between 1 to 20 euro per megawatt hour, so 1 to 20 euro per guarantee of origin, and it is very heterogeneous in Europe. Because it depends on local politics, feed-in tariff for subsidies. And the guarantee of origin are not the same and with the same substrate and in the different market. One of the reasons is that biomethane is quite new. So the market right now is really new, and it's the first years where some public authorities, municipalities, or industrials can find guarantee of origin, can find biomethane and try to ask for it. In, I would say, 2 to 3 years, we will have a clear view, we will have a better idea of what would be the biomethane demand, so on what would be the biomethane price for the guarantee of origin.
Yeah. And another question is, why are there so many AD plants in Germany compared to the other countries? What should we export from the German model to other countries?
That's a really good question as well. I will let Youssef complete that. But so the German market has been really incredible between the year 2000 and 2010, developing almost 10,000 plants in 10 years. This plant has been developed with a very high electric feed-in tariff first, and pushing also, I would say, energetic crops. The fact is, right now, this market has this bubble, I would say, has exploded, and this market is really has really decreased. Why? Because the energetic crops are really expensive to produce, and the electricity production has a very low efficiency. So the electricity produced from biogas in Germany is very expensive. So now the German market is switching, where we will have to use more waste to reduce the cost of a substrate, and we have to produce biomethane, which triple the energetic efficiency of production. On doing so, we will develop the German market. I would say that what we have to do in the other European countries that are, I would say, free of AD plant, is to start on the good recipe. So using waste to produce biogas and producing biomethane from this biogas. And through this chain, we will develop a sustainable market. The German development in the year 2000 to 2010 is not sustainable. It was just an effet d'aubaine. Youssef, if you want to complete.
And another thing in Germany, I think that they are the first one to have done a lot of research in the technology, etc., and this has helped a lot. And there is something else in the German market that we can't find in all the other markets is social acceptability. For example, here in France, one of the major problems that has led to, let's say, to a late development of biogas and AD plants is the social acceptability and the let's say the regulation all around this. Yeah, for me, one thing to export, if I want to say it like this, from Germany is this mentality of accepting and let's say making the technology more or closer to the people, so they will have more acceptability to the projects. I don't know if you think the same, Mathieu.
Yes, I think on the evolution in the next couple of years is that so German people were more able to accept biogas plant because there are really I would say, how to say that, happy to have a renewable energy. Nevertheless, the fact that most of this energy come from maize, from genetic crops, so the fields are not used to feed the planet but to feed digester and to produce energy, has not been appreciated at the end of 2010. So now the switch is to really to use waste, and this will be much more accepted than energy crops.
In France, you would correct me, Mathieu, but I think in France that we are not, for example, have we ever been allowed to do energy crops, dedicated energy crops?
It is allowed for biofuel, liquid biofuel.
Yeah.
It is allowed on very small amount. No, it's not allowed on anaerobic digestion. What it allowed is intermediate crops, which not compete with food production.
Yeah. So what we call culture intermédiaire, vocation interdiutique. Yeah, exactly. So those are, and I think there is a limitation of 15% that you can use in the AD.
It's still in discussion, but it's allowed and there is limitation.
Yeah.
But this is a very nice solution to enhance the production without affecting the food production.
The food production, exactly, yeah. Which was a problem, for example, in other countries like in Brazil, where and in Mexico, etc., where there was big strikes in 2010 and around 2010 because basically it was more, let's say, interesting for agriculturers to use their crops for energy production than feeding the people. So, for example, the price of maize, etc., have risen lots. So it has created a lot of social problems. So this is why what we are trying, for example, here in France to avoid, basically.
Biofuel from organic matter without using energy crops is a very environmentally sustainable way to produce clean energy while not affecting the food production.
I totally agree.
Right. So we have the time to take another question now. Okay. One of the problems with methane is its very high greenhouse gas potential, more than CO2. If we generate more methane by biodigesting organic materials, is there a risk of leaks of CH4?
So this is a really nice question as well. So people we are really happy to answer this question. 2 points. Yes, the methane leak could be and is right now very important, very big problem for the climate change. And it's one of the reasons I founded Waga Energy, wasted gas energy, because 3 to 5% of greenhouse gas emissions come from landfill gas. So the biogas, which is produced from our waste and emit to the atmosphere, and this is not sustainable. So we have to collect this gas and to use this sustainable energy to substitute fossil energy instead of polluting our atmosphere. Regarding the development of anaerobic digestion plants, the impact is the opposite if it's done well, I would say. So I will explain. If the substrate from agriculture is used to produce biogas, and that will produce biomethane to substitute fossil energy in a good plant, nice industrial plant, with no leak and with very high recovery rate of methane. This is really benefit for the planet, because the substrate that are usually expanded without being digested on the field will not produce methane. The digestate from the anaerobic digestion is really better in terms of fertilization without any emission, and you substitute fossil by renewable. Nevertheless, if you don't use, I would say, the proper technology or good enough technology, you will have some leakage, you will have low recovery rate for the upgrading, and you could have more methane emission, which will annihilate the benefits from this. But today, the technologies and the industrial approach for producing biomethane is really high enough, good enough to achieve very nice environmental metrics.
So we have,
yeah. Well, I totally agree with Mathieu, but the only thing that we have to take into consideration as well, as Mathieu said, I totally agree with what Mathieu said. Sorry again. But the technology, we have to know that the technology is mature enough, the technology is used well, and that the risks of leaks are really rare. So I think it is not, let's say, a big deal, because there are no like major risks at the moment concerning the technology and the leaks of biomethane from it. This is the only thing I wanted to add on what Mathieu said.
On the same subject, there is someone saying here that apparently accidents of methane-powered vehicle can be very dangerous. So again, we speak about risks. We don't know really about that. How cope with this? The question goes again: if a methane-powered vehicle is involved in a collision on a very high-speed road, is there a high risk of fire or explosion more than with the petrol? It's a catastrophe. Yeah.
But the thing is that vehicles fueled with biomethane have the exact same technology than vehicles fueled with natural gas. So it doesn't present any, let's say, added risks compared to the ones fueled with natural gas.
So what I will add is that the methane-powered vehicles, the methane, so what we say gas natural vehicle in France, CNG, compressed natural gas, is the first alternative fuel in the world, the first alternative to petrol fuel, meaning on the faster expanding fuel, meaning that China, India, Argentina, Italy, Pakistan, etc. All these countries are developing very quickly the natural gas as a vehicle fuel, and it's really common in this country. In France, as an example, we are really late in the development of this very nice fuel. This fuel is not pollutant for city centers, so you can solve the pollution problem in cities. And these developing countries has understood this and are in front of us regarding a cleaner future, I would say, or cleaner cities. So there is no more rate, I think, but I will not develop this because I'm not the expert, but what is sure is that methane as a vehicle fuel is developing very fast in a lot of countries, and I would say all countries that are still in petrol has to move fast and to change the infrastructure to go to the 21st centuries instead of being still in the 20th centuries.
Okay.
And another thing that's another problem for the development of those cars is also the network. The fact that we don't have a lot of networks for refueling stations for using bio-CNG or CNG in general, and this is why it doesn't develop as fast as other countries. Like, for example, in Italy, it's quite developed, right? And as you said, in Pakistan, in other countries. In France, some actors, for example, Air Liquide is working on the development of those stations. So in the future, in the near future, there will be more opportunities for the development of these markets.
Okay, maybe we'll take the last question because the time is running, or maybe a last one. We'll see how long you take to answer that. Do you think the possibility to generate biogas biomethane in our houses for fulfill our energy demand. Yeah, sorry. To read that.
Especially in China, for example, most of the villages are equipped with anaerobic digestion plants, and the biogas is used for cooking. So this is, there is perhaps 100,000 of anaerobic digestion plants in China that are developed to treat the substrate, to treat the waste, and to produce biogas that is burned in a boiler or in a cooker to cook. I'm not sure that in developed countries we will go in such decentralized way of producing biogas, because the quantity of waste generated by one family in one house is really small, and you will not benefit from economies of scale or an industrial approach. Biogas is definitely a decentralized energy, but my point of view is that we will concentrate quite a bit this waste to invest in an aerobic digestion plant, which is quite expensive, to make economies of scale and to produce biomethane as cheap as possible, because the idea is not to produce a renewable energy which costs 10 times fossil energy, it's to produce a renewable energy which competes with fossil energy. And this is, in my point of view, achievable on a house scale.
This is the problem. The economical problem is the problem of the development of what we call micro ADs, so micro anaerobic digesters, or like used by, for example, just one small farm or just a group of persons or something like this. So the economical problem is the major problem for the development of this market.
But perhaps the last one.
Yeah.
We take a last one?
Yes, definitely. Yeah.
Do you think that the coal bed methane gas can be a serious competitor to biomethane?
Clearly, I would say not. Why? Because we are looking for the next 100 years or 1,000 years. Biomethane is a renewable energy, which means that in 1,000 years we will still have biomethane. Coal methane is an energy from fossil energy, so it's finite, it's a limited energy. So even if we use the coal bed methane right now for the next 10, 20 years, then when we will have used it, it's finite. You cannot reproduce it. Biomethane is regenerated every year with the biomass growth.
Yeah. That's it. Yeah, I think you mentioned everything, and yeah.
Yeah. So we will have to let you go. Thank you very much, Youssef and Mathieu.
Thanks a lot.
It was great to have you today. And we meet you again next week for the hydrogen energy live session, same time next week.
And keep on following the MOOC.
Thank you. Bye.
Bye-bye.
Bye.